A sequence in math is just a list of numbers, and so we could really have anything for a sequence. We could start with 2, we could put a 4 down, and then a -8, 10, 1,000, -40. This would be considered a sequence. So it's just a list. A sequence is a list. The kind of sequences that we care about in Algebra 2 are recursively defined sequences. And what that means is we have a list of numbers that are developed by this, or that come about from this process of recursion. Recursion is where each step in a pattern is dependent on the step that came before. So going back to this first example I gave you, you know, it's really difficult to see if there's a pattern here. So we can't say that recursion is going on because we don't see a pattern. However, what I can do, let me switch out colors here. What I can do is I can come up with an example of where I do have a pattern and where every step in my list comes from the step that came from the one before. And you have an example of this on your outline. So if you look at 2A on your outline, I define sequence and a recursive sequence for you in easy terms. This is not a textbook definition, just easy terms. So a recursive sequence is a list of numbers where you get the next number by doing something to the previous number. So let's look at a list of numbers with a pattern. And notice that you can get the next number, let's say, by looking at the step that came before. And what did we do to the step that came before? Well, every time we're adding 2. So how would I get the next number after 12? I look at 12, I add 2. So the next number is 14. And we could continue this pattern on and on and on. So that is a recursively defined sequence. So let's look at an example of this. Most of the time in the real world, or I would say all the time in the real world, we're not given a formula. We're not given an equation. What we're given is a scenario or data that we have to put into a table. We have to organize in a way so that we can come up with an equation, a formula, a way of presenting it to other mathematicians or other people in general. So it always is going to start with some data, which is why sequences are so interesting to study, because that's just the data. So let's look at this example and we'll see what we can pull from it. Here we have one table that seats 4 people. If I add another table, I can sit 2 more people. If I add another table, I can sit 2 additional people. And so the scenario is essentially that for every table I'm adding, I can sit another 2 people. And the question asks, 3 tables pushed together seat 8 people. How many people can sit at 10 tables pushed together? So if I continued this pattern again and again and again and had 10 tables, how many people would sit there? Well, I can organize this into a table of data. Let me pull up a different slide here. And so I have 1 table seats 4 people, 2 tables seat 6 people, and I got this from the previous drawings on the last page. 3 tables seat 8 people, 4 seat 10, 5 seat 12. Well, I can just keep doing this until I get to 10 tables, 15 tables. I'm just adding 2 each time. And this is how I can answer the question. So a sequence is an ordered list of numbers, and the table in here in this example represents the sequence 4, 6, 8, 10, 12, and so on and so forth. We could just keep going on this manner. So here is the data. Here is our sequence, 4, 6, 8, 12. So we have to talk about a couple definitions at this point so that we can continue to talk about sequences and look at different scenarios and examples and maybe get a little bit more in depth with our understanding. So going back to your outline, if you look at 2B, there's this term called arithmetic sequence. And I'm asking you to define arithmetic sequence and common difference. Now this is defined in your book, which you probably don't have yet, so I'm going to talk about it briefly here. This is an example that is an arithmetic sequence. So an arithmetic sequence, sequence is a sequence where this difference, so let's go back to this example, 4, 6, 8, 10. Here's my sequence. Notice that I'm adding 2 each time. I'm adding 2. So I'm performing arithmetic, in a way, on this list of numbers. So that is an arithmetic sequence, is that I'm adding each time. Now, I'm going to say here you can also subtract. And what this number is right here, this plus 2, positive 2, positive 2, positive 2, this is your common difference. Common difference. So an arithmetic sequence is a special type of sequence that has a common difference. So the pattern that is occurring in the list of numbers is either adding or subtracting each time. We call that a common difference, and that makes an arithmetic sequence. So we also have a geometric sequence. Now, a geometric sequence would be, I'm going to get a new page here. So a geometric sequence use short term. A geometric sequence would be, for example, if I had 2, 4, 8, 16, 32. Now here, I'm not adding or subtracting, I'm multiplying by a number. The pattern is multiplying by 2. So what we call this guy, this multiplication by 2, this is called a common ratio. So this 2 right here is our common ratio for this geometric sequence. So there are 2 kinds of sequences that we care about, arithmetic and geometric. So here is an example of an arithmetic sequence, 3, 6, 9, 12, 15. And here's an example of a geometric sequence, 4, 12, 36, 108. An arithmetic sequence is a sequence in which each term is equal to the previous term plus a constant. And that constant can be a positive or a negative number. So in this example, 3, 6, 9, 12, 15, the common difference is positive 3. And then on the other hand, we have a geometric sequence. A geometric sequence is a sequence in which each term is equal to the previous term multiplied by a constant. So the geometric, we have 4. 4 gets multiplied by 3, because that's our common ratio. 12 gets multiplied by 3 to give you 36, which gets multiplied by 3 to give you 108. So hopefully you're seeing the difference between arithmetic and geometric sequences. Note that both of them are considered to be recursive, because you have to do something to the previous number to get the next number. And that there is your introduction to recursive sequences.